students, today's lesson is on solving systems of linear equations by graphing. Let's start with some vocabulary. A system of linear equations is a set of two or more linear equations in the same variables. And a solution of a system of linear equations is an ordered pair that is a solution of each equation in the system. In other words, the solution of a system of linear equations is the point of intersection of the graphs. So it's the point where the two lines meet. So we're going to solve a system of linear equations by following these three steps. We're going to graph the equations in the same coordinate plane. We're going to estimate the point of intersection. And then we're going to substitute the value that we found for that point back into the original equations. So let's go ahead and try that. We're going to use these two equations that are on your sheet, y equals 2x plus 5 and y equals negative 4x minus 1. So let's graph those two equations. The first one, our intercept is 5 and our slope is positive 2. So our line is like that. And then our second equation, the intercept is negative 1, and our slope is negative 4. Okay, so you can already kind of see, my line isn't super straight here, but after we do our first step, which is to graph, we can estimate the point of intersection. Looks to be at negative 1, 3. So our next step is to take each of these equations and substitute the point negative 1, 3. Negative 1 for x and 3 for y, and see if our equation is true. So y equals 2x plus 5. I'll substitute 3 for y and negative 1 for x. 3 equals negative 2 plus 5. 3 equals 3. That's true. And we have y equals negative 4x minus 1. 3 equals negative 4 times negative 1 minus 1. 3 equals 4 minus 1. 3 equals 3. That's also true. So that point is on both of these lines. So it must be the point of intersection. Okay, for the second example, we are going to write the two equations, and then we will find the solution. So, a kicker on a football team scores 1 point for making an extra point and 3 points for making a field goal. The kicker makes a total of 8 extra points and field goals in the game, so 8 total kicks, and scores a total of 12 points. Write and solve a system of linear equations to find the x number of extra points and y, the number of field goals. So we're going to start with a verbal model. So we're going to write out what we're finding here. So we're going to say the extra, let me just simplify this and say EP for extra points plus field goals equals total kicks, right? Extra points we're going to call x, plus field goals we'll call y, and the total kicks we were told is 8. So that's one of our equations. Now, the second one is a little bit more complicated because we need to take into account how many points you get. So we're going to say points per extra point times the number of extra points plus points per field goal times the number of field goals equals total points. Okay, so we know we get 1 point per extra kick, so that's 1 point for every extra kick, plus 3 points per field goal, that's 3 times y, the number of field goals, equals 12 points. So here we have two equations that we are going to graph and find the solution. Okay, so step 1 is going to be to graph. So our first graph is x plus y equals 8. Let's go ahead and label our axes. We know that extra points is on the x-axis. And we'll number those 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Field goals on the y-axis. We'll label that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So let's start with graphing x plus y equals 8. If we think of this, it's written in standard form. That means if there were 8 field goals, there's 0 extra points. If there's 8 extra points, there's 0 field goals. So we can graph it like this. Okay. We can also graph our other equation. Let me do that in another color. So we have 1x plus 3y equals 12. This one might be a good one to put into slope-intercept form. So I'm going to rewrite this as 3y equals negative x plus 12. Divide both sides by 3, we get y equals negative 1/3 x plus 4. That makes it a little bit easier to graph. So we know our y-intercept is 4. And then we have a slope of negative 1/3. So we'll go down 1 over 3, down 1 over 3. And I can kind of see where it's going to intersect right here. Draw my line. Okay. So by graphing these, it looks to me like the point of intersection is at 6, 2. So that's going to be our estimate. Now we'll put this point back into each of these equations to check. So we have x plus y equals 8. 6 plus 2 equals 8. 8 equals 8. That is true. And then we'll use our other equation. 1x plus 3y equals 12. 1 times 6 is 6, plus 3 times 2 equals 12. 6 plus 6 equals 12. That is also true. So this point 6,2 is on both of the lines. That means it is our solution. All right, go ahead and try a few on your own. I'll see you soon.